Okay, so this is probably the lowest tech version of a problem I'll do, but this is my first time using this program. So kinematics means constant acceleration, which has a whole set of special equations, and I'll talk about where those are derived from later. For right now, all you need to know is that anytime you're doing a kinematics problem, which something in free fall is kinematics because gravity is a constant acceleration, you have 5 variables. So I have initial velocity, final velocity, acceleration, displacement, and time. You'll notice I have a down picture and an up picture because you can't put them together. The reason you can't put them together is because the acceleration on the way down, in this case, is negative, and on the way back up is positive. It's accelerating as it falls to the ground, and it decelerates as it's flying back up in the air. All right. So we'll deal with the down part first. Here's the information we know. Oh, sorry about that. Here's the information we know. Initial velocity is 0. It was dropped, not thrown. The acceleration due to gravity, because they told us which way to make negative, is negative 9.8 meters per second squared. And the displacement is also negative 2.05 meters. So there's 2 pieces of information we don't know anything about. When you're doing kinematics, these are the 5 kinematics equations, and if you'll notice, each one's missing one of the variables. This equation doesn't have displacement. This equation doesn't have final velocity. This equation doesn't have initial velocity. This equation has no time, and this equation has no acceleration. And I'll show you again at a later date how these equations are derived, but they're very useful. So I'm going to pick the equation without time because it's asking me to solve for v, and it doesn't give me any time. So v squared equals v naught squared plus 2ad. We substitute in our values, we do a little algebra, we get 6.34 meters per second. Now because of the system they chose for this particular problem, I'm going to go ahead and put on the negative sign here to show that it was falling down the split second before it hits the ground. For the second part of the problem, we're looking at when it bounces back up. So it's left the floor. So at the top of its flight, its velocity is 0. Its acceleration is negative 9.8 meters per second squared. And it flies back up at 1.91 meters. So I, again, choose the equation without time, substitute in my numbers, and I solve. So I get that it's only going at 6.12 meters per second when it leaves the floor. So it's lost some energy. All right, so now I can go back to our column for part C. They give me a time, and so now I'm going to choose a new equation. And with this new equation, I know my final velocity that it leaves the floor with. I know my initial velocity that it hits the floor with, and they've given me a time of 0.08 milliseconds. Keep in mind, my finger covered it. Milli means 10 to the negative 3. So if you do a little algebra here, one equation, one unknown, you can solve for the deceleration. Let's see if I have anything else. So then for part D, it asks you to find the displacement. Try that one on your own. If you're still stuck, ask me for help and I'll walk you through it, but you're just going to go back and pick one of these equations, either for the up, the down, or the collision. So there's actually 3 different parts of this problem that you can do kinematics for. Okay, I hope that helped for number 3. Thanks.